We're going to talk about how internet works at a very high level in this video. Let's assume that we have a browser within a device. It could be a mobile device or a computer, and this device is part of a network. It could be part of your home network. So if you have connected to the internet using your home Wi-Fi router or something like that, or it could also be a corporate network where you are accessing internet using your work computer, for example. Now let's assume that the user wants to access google.com. So they type google.com in browser's address bar. First thing the browser does is it cannot just use the URL to communicate with Google. It needs to find out the IP address of google.com. So browser reaches out to domain name system. This is a service usually provided by internet service provider or someone else like Google, for example. When you connect to the internet, domain name system is automatically configured for you by your ISP. So your browser knows how to contact DNS. Now, after a user has typed google.com, it goes to DNS and gets the IP address of the google.com URL. Now your browser has the IP address. The first thing it does is it creates a message with the source IP address as the device's IP address and the destination IP address as the google.com's IP address that it got from DNS. And this message is sent to the home or corporate network's router. So if you are part of home network, for example, then you will have router at your home, and browser will send this message to the router through which you have connected to the internet. So internet is made up of several routers like these, and these routers are somehow interconnected. So there will be many such routers between your home network and the network used by Google to host their servers. These routers will have something called a routing table, and these routing tables will contain known networks, the networks that can be reached from these routers, and also next hop. Next hop indicates where should we send this message next in order to send it to its destination. So once the message has reached our home or corporate network's router, it needs to find the next suitable router. There are some protocols like border control protocol and routing information protocol that helps to identify what should be the next hop. Because for example, from this router, we could reach multiple different routers. We need to pick one router to send the message to, right? So, and to do that, we'll be using these kind of protocols, border control protocol and routing information protocol. So usually we'll be identifying the next router which are one step closer to the destination network, right? In our case, it is actually Google's network. Let's assume that from our home network's router, we go to this router using the route table information and also using these protocols. And from here, let's assume we go to this router and so on until we reach the router that is part of Google's network. Once we reached router within the Google's network, the router needs to decide where it should send that message to, because within that network there could be several servers and it needs to find out the right server to send these messages to. For example, within Google's network, you could have one server for google.com and another server for YouTube and one more for Gmail, for example. But you want to reach google.com. Now, this router, which is part of Google's network, got the message and it also has the destination IP address. So what it does is, it announces within the network that I have a message for this particular IP address. Who has this IP address? So there will be several servers within the network, but each server will have unique IP address. And one of them, in our case, google.com server will have the destination IP address that we have in our message. And this google.com server will reply to the router saying that the IP address belongs to this server. Within that reply, it will have something called MAC address, which is media access control address, which is a 48-bit unique address for this particular server. Once the router has the MAC address for the right server, it will send the message to all the servers within the network with that MAC address. And only the server which owns that MAC address will process that message. So in our case, the request to open google.com has reached our server, and now this server responds back. And for the response, the communication chain is exactly same, but this time source IP address will be google.com's IP address and the destination IP address will be the browser's IP address. But the communication will exactly be same. It will go through these series of routers to reach the destination, in our case our browser, and this response will be HTML document that is displayed on the browser. Okay, so this is how at a very high level internet works. I have deliberately glossed over a lot of details, but this will give you some high level idea of how internet works. Hope this is useful. Thank you.